Hello and welcome to the AddMorePower Project. Today we have met up with a project partner from ESRF. Hi, please introduce yourself.
So, I'm Cedric Corley-Wiciak. I'm a postdoctoral researcher at the European Synchrotron Radiation Facility in Grenoble, France. And my job is to lead the work package 3 of the AddMorePower Project, which is focused on the structural characterization of the materials in a high-power transistor by advanced X-ray based characterization methods. So generally, if you want to do characterization by X-rays, there's two types of laboratories where you can do this. There are either the smaller laboratory sources, which are typically based on rotating anodes, and the large-scale facilities, those are the synchrotron radiation facilities, and I work at the latter. However, the work package employs both for different purposes, and my job is to coordinate between all the different participants in the work package, and also by myself and with my colleagues and collaborators to conduct experiments at the ESRF. So to perform measurements, to analyze the data, and use that to provide feedback to the user, to the project consortium.
Thank you. What's special about this project consortium?
What makes the consortium special, I would say, is that it's scientifically quite diverse. So basically we try to tackle this problem of characterizing the structural degradation of high-power devices from all angles. And this has brought together not just a very deep, but also a very broad expertise, because you have people who, like me, are specialized in X-ray based characterization techniques. You have partners who are specialized in electron microscopy based techniques. You have experts in different types of simulation and also for different types of materials, because the consortium is really aiming at characterizing not just one material that is used in a functional device, but really to look at everything that is a part of the device and to understand all the possible failure mechanisms. And I think this is really quite unique, because at least I have the impression that very often people tend to pick one topic or one particular effect and try to study that. But of course, if you want to look at a real-world problem, as we do, then you really need to look at everything that the device is made of. So the semiconductor, the metal, and everything that can happen to those components while it's operated.
Why is this project such a unique opportunity?
Basically, that we have such a diverse team and such a vast wealth of technical expertise is really opening the way for some cross-correlative studies. So I don't just have to rely on my synchrotron results, but I can take those and compare them to what the other people in the consortium are doing, and also verify it by simulation to develop models. Also, we have people who have a very deep understanding of the device and the materials themselves, and that allows us to interpret our experimental results and theoretical results in a reasonable manner and understand what it means and how it can affect the performance.
Thank you. And for our audience, if you want to know more about this project, head over to addmorepower.eu.